Hey everyone, Ian Akone here. I'm going to go through the Module 2 problems and send you this video and then also this handout because we're not having class on July 4th. So if you look at this, this is a one-step equation, and you know that we want to get the letters on the left side or the right side, doesn't matter, and then the numbers on the other side. So we do that by attacking this -3, you add the opposite, and you add the 16 plus 3, you get the 19. And then I've checked every single problem over here. That's what the little green check means. So for this one, the fraction, don't panic, fractions are numbers. They look different, but so here you can say the rule is multiply by the reciprocal, but you can also think of this is 4n, and hopefully you know to get rid of 4 times n you would divide by 4. Well, that's what the 4 on the bottom does in effect. It's 4 divided by 4. And then with the 5, hopefully you know if you have 5 on the bottom of a fraction, you would multiply to cancel out the 5. And in effect, that's what we're doing here. You see the 5 and the cancel. So all this business cancels, and then you multiply by the same thing over here, and we get 10. And then, look, I checked it, of course, and 8 does equal 8, in fact. So it checks. So let's look at number 3. So this one step problems. Hopefully you know 2 times m, the opposite of multiplication is division, and we divide both by 2. And I didn't write divided by 2, but you get 14.2, and then it checks over here. So hopefully I'm not going too fast, but I suppose you can rewind. We got 38 problems to get through. So similar to the one up above, we divided by 19 to cancel out the 19 in the denominator. You would multiply both sides by 19. And here, I'm in the habit of putting 1 on the bottom as a placeholder. So you know that the 19's in the numerator, in the top. And that's just a placeholder there. Cancels out, multiply by 19, bam, it checks. And if you're not familiar with what that means, the check is because I put the 28.5 here, I divided it. And because I get 1.5 on the left, and there was already 1.5 on the right, because those two numbers are the same, then that means that that 28.5 is correct. If this number had been different from 1.5, then our work would have been wrong. But that's what a check does. So once again, one-step equation. Hopefully you're familiar with subtract 12 from both sides, and then it checks. All right, they'll get increasingly harder. Well, this one tried to surprise us with the y on the right side. A lot of people aren't familiar with it. Just looks different. You see the y is on the right side. It's okay. Y is -4. Same thing, you divide by 14, cancel out, you get the -4, and it checks nicely. So here's a 2-step equation, and looks like I'm showing you 2 different ways to solve it, because most math problems you can. So look at this up here. This is the first time seeing this probably. And it might be different, but let's see. Multiply each term by the lowest common denominator. And you don't even have to do it by the lowest common denominator, which would be the lowest number that all of the denominators go into. You could pick any common denominator. But look what happens when you multiply every single term by 3. Because 3's in the bottom here. 3 over 3 cancels, and then 4 times 3 is 12, and 3 times 7. Look what it does. It gets rid of the fractions. Fraction, no fraction. And from here, you subtract 12, and you get 9. So this method becomes way more powerful the more fractions you have. It just cleans the problem up. But it's a new step. I get it. That can be tough, learning a new step. Here, I solved it the old-fashioned way, if you want to say that. Oops. When we're undoing these equations, you really are doing the order of operations in reverse. So hopefully you remember the order of operations is when you're solving is you do multiplication and division first, and then you do addition and subtraction. Well, because we're undoing this equation and we're trying to find out just what x equals, you do everything in reverse order. That's why you subtract 4 first and then multiply by 3, and look, you get the same number. You get the 9. We'll go over this method a lot because you'll like it. Once you get used to it, you'll like it a lot. You don't have to, of course. So here is a two or three step equation. So here, it doesn't, I've chosen to subtract 5y from both sides. You could have subtracted 8y, you could have subtracted 9, you could have added 12. Doesn't matter. You get the same exact answer. Now, I realized that if I subtract 5 here and subtract 5y here, I get a positive y, a 3y. And then in my eventual answer, I'll have a positive y. I won't have that negative sign in front of it. You don't have to do that. But look how I predicted. It's really predicting how the problem is going to come out. Do you see that? So then once I subtracted the 5y, we're doing that order of operations in reverse. So we handle the subtraction before we handle the multiplication. And I add 12 to both sides to cancel it out. And then I would divide by 3 and then get you 7. And then I checked it. So let's look at 14. Ooh, they get tougher fast. They get longer fast. So here, we've got to distribute this 3. You don't have to. There is a way to do it without distributing the 3, but the problem gets longer. It gets a little messier. So if you ever have a situation like this, do the 3 times the x, and then the negative 3 times the negative 2, and you get the negative 3x, and then you get your 6. And then let's take a look at these notes up here. I'm in a big habit of putting parentheses around everything and keeping the negative sign inside the parentheses. That's what this business is about. And then, see, I put a plus in between here. So you can do it this way. You don't have to. But if you don't put those negative signs, I've seen it real easy to forget some of them. And then this would have come up -6, and then unfortunately you get the problem wrong. So I'll do this a lot in class. And then next, our module 3, I'll solve a lot of these. So then we solve it same as the last couple, and then we get -4/3. Now, when I go to check it, I could have put in -4/3, but because I'm checking it, I'm going to just put -1.33, just put a couple of decimals there. So if you go through and you're solving it, you multiply by 3, I get 9.99, which is close enough for checking it. Because if I had put -1.33333333, I would have got 9.9999999, which is in effect 10. Now, if I'd have put a fraction in there, I would have gotten exactly 10. But I know decimals, I know checking, I know that that's going to be right, the 9.99. So let's go on to see, look, they get more and more distributive property. Now look at this tricky, whoever wrote this tricky math teacher. There's a -4 sign, -4 on the negative sign on the 4. Look, I'm keep the negative with the 4 and the 3. That's what that is. Look, see? And at the same time, I'm distributing it. So that is a -4. And it also means subtract 4. They mean the exact same thing. But if you remember from, a long time ago in elementary school math, plus and negative is the same thing as subtracting. So I kept the -4 here. Now you will see a problem exactly like this on all your tests because they're trying to trick you. It's an easy problem to forget that negative sign there, and then you're multiplying to get the +12, the -4a. Look at, we're combining like terms, subtracting the 12, and There it is. On these problems, because every single problem is worth like $5 for y'all to take, because I've broken it down. If you're not confident in math, you might want to write every single step with all the parentheses and everything, because if you get the problem right more often when you show every step, then that means you should always show every step because you're getting them right more often. So let's go to 18. Look at this double distributive property. Tricky teachers. Once again, the -3 kept it. Distributing -3. Look at that. Another -3 kept it there. Distributed the 9 all at the same time. And then if this helps you, the little arrows so you know what to do next, then write them every time if you're getting them right more often. So that's my -3y. Here is, you see the 9 right there? That's the 9. You see that right there is the 9y, and then that's the 9. Combining like terms, just like 2 problems ago, I'm going to combine like terms and put the 4y with the 9 so I can have a positive y. And then here, I've seen folks get confused and subtract 9 from this side. You want to get rid of this 9 right here. Although in this problem, the answer is 0 because 9 minus 9 is 0. So we're subtracting by 9 on both sides and we get 0. And then you divide by 5, and 0 divided by 5 on your calculator is 0. So I'm going to pause it and then make a part 2. Bye.